Okay, so I asked you to do number 1 and 2 on this sheet. Seems wrong to waste the back side of a sheet. So number 1, you're driving 64 meters behind your favorite physics teacher in your fancy car. Both of you are traveling 15 meters per second. So there's the student, or you, and the teacher. Okay? And it says both of you are traveling 15 meters per second. So your VI is 15 meters per second, and the teacher's VI is 15 meters per second. You get tired of going so slow, so you pull out and pass, accelerating at a rate. So your acceleration, 3 meters per second squared. Your physics teacher innocently accelerates at a rate of 1.4 meters per second squared. Not that she doesn't want you to pass her. How long does it take you to catch up? How far have you gone? So if you think of what's happening here, right? So here you are, and here is the teacher's car, and this distance in here is 64 meters. So you decide to pull out and pass. So while you're doing that, she's traveling some distance. This is delta D of the teacher. So you need to travel this distance to catch up, delta D of the student. So looking at the picture, you should be able to see delta D of the student should be equal to delta D of the teacher plus 64 meters. Okay, so this is our equation that's going to connect the delta D's. Whatever the time is, it's going to be the same for both of them, but we don't know what it is. Okay, so we're going to have 3 unknowns: the time, the delta D of the student, and the delta D of the teacher. So we need 3 equations. Okay, so we have one equation right there. Our second equation will be delta D of the student is equal to VI delta T plus 1/2 A delta T squared. And for the teacher, delta D of the teacher is equal to VI delta T plus 1/2 A delta T squared. Put a T or a 2, an S or a 1 on your A's because they're different. Okay, so now we can fill them in to our delta D of the student equals delta D of the teacher plus 64 meters. So where delta D of the student is, we can write VI delta T plus 1/2 A student delta T squared is equal to VI delta T plus 1/2 A teacher delta T squared, and don't forget the plus 64 meters. Now this might look really nasty, but it isn't, because the VI's are the same. And because the VI's are the same, these two terms are just going to cancel each other out, because the VI is the same and the T is the same, and they're on opposite sides of the equal sign. So now bring your 1/2 A delta T squared over, so your T squares are on the same side. And I might multiply by 2 while I do that. So A of the student, delta T squared, minus A of the teacher, delta T squared, is going to end up equaling, multiply this by 2 as well, 128 meters. And now we use that little trick we've been using, factor out the T squared. So it leaves us with A of the student minus A of the teacher is equal to 128 meters. Divide both sides by the bracket, so 128 meters over A of the student minus A of the teacher, or 128 meters over 3 meters per second squared minus 1.4 meters per second squared. That's 1.6. I think you get 80 seconds squared here. Take the square root. Delta T should be 8.944 seconds. That's how long it takes. Second part of the question says how far has each traveled. So now you need to take this 8.944 seconds, fill it in for the student, fill it in for the teacher. And if they end up being 64 meters apart, then you did it right. So delta D of the student will be 15 meters per second times that 8.944 seconds plus 1/2 3 meters per second squared times the 8.944 seconds squared. And when you do this, you should get delta D of the student to be 254.157 meters, especially if you kept all your decimals on your time. I did in my calculator, I just didn't do it on the sheet. delta D of the teacher, filling it into this one, and I'm not rewriting the equation just because I'm trying to save time here. So 15 times 8.44 meters per second plus 1/2. The acceleration this time is only 1.4 times 8.944 seconds. Don't forget to square it. Delta D of the teacher is equal to 190.157 meters. You can now get up and do a happy dance around your room because they are 64 meters apart, which means you did it right. Number 2 says, you are traveling 72 kilometers per hour in your truck when you pass a friend who is stopped. So it's you and its friend. So you are traveling 72, and when you switch 72 kilometers per hour to meters per second, it's 20. And you pass a friend who is stopped, so their VI is 0. I didn't write anything for your V because I haven't read the rest of the question yet. Your friend speeds up to catch up to you, accelerating at a rate of 4 meters per second squared. But to bug your friend, you accelerate, so this is a VI. To bug your friend, you accelerate at a rate of 2.2 meters per second squared. How long before your friend catches up to you? Okay, so here you are. Okay, you pass your friend who initially is stopped. They speed up to catch up. Your times and your delta D should be the same. Okay, so we have two unknowns, your delta D and your delta T. For both of you, they're the same for both of you. Okay, so two unknowns, we need two equations. So delta D of U will be VI delta T plus 1/2 A delta T squared. For your friend, delta DF, VI delta T plus 1/2 A of your friend, delta T squared, but this goes to 0. Okay, so we can set them equal because delta DU is equal to delta D friend. So VI delta T plus 1/2 A for U delta T squared will be equal to 1/2 A of your friend delta T squared. All three terms have a delta T in them, so you can divide each term by delta T to make your life easy. It means it will not be a quadratic. Okay? So you'll have VI equals 1/2 A of your friend, delta T, I'm going to bring this guy over, minus 1/2 A of U, delta T. You might want to multiply both sides by 2, so it'll be 2VI is equal A of friend, delta T, minus A of U, delta T. Factor out the delta T. A of friend minus A of U equals 2VI. Divide both sides by the bracket. And so you'll have delta T is equal to 2VI was 20 meters per second. A of your friend was 4 meters per second squared minus A of U was 2.2 meters per second squared. So you get a delta T on the top, that's 40 meters per second. On the bottom, that's 1.8 meters per second squared. When you divide them, you should get, I think it's 22.2 repeating. 22.2 repeating seconds. Okay, now once you have that, the question says how long, and then it says how far have you both traveled. So now I'm going to run out of time, but you go up here and you fill it in. Delta D of the friend is equal to 1/2 4 meters per second squared times 22.2 repeating seconds squared. And you should get a delta D for your friend to be 987.654,321. You don't really need to keep all of them, but I kind of like that answer. 987.654,321. And over here, if you do the same thing, you should get the same answer. So it's going to be 20 meters per second times 22.2 repeating plus 1/2 2.2 meters per second squared by 22.2 seconds. Don't forget to square it. And lo and behold, if you didn't round at all, 987